Okay, so we're going to switch from a very small device to much bigger device with Yocto. I am French, really. I'm a Linux developer, a writer and teacher, and currently I am a CTO for a company called Small ECS. It was OpenWide before, but now it's Small ECS, which means embedded and connected systems. So I will talk about using Yocto in IoT world with the first use case with a sensor based on a small Raspberry Pi Zero. And the second example would be an example from people from Toulouse at Smile ECS and using a Raspberry Pi running Yocto, but just for a border router. So oh, sorry. Facebook is everywhere. So there are several kinds of objects. We talk a lot about basic objects such as sensors with microcontrollers, and sometimes the software is bare metal or some lightweight such as Contiki. When we talk about Riot, there is another operating system very famous and quite old, which is called Contiki. And the second class of object is it's a computer. It's a kind of computer with a high-speed CPU and an OS such as Linux, Tizen, or Android. So there are some examples. This one, it's I don't know if it is famous out of France. It's a parrot, flower power. It's a sensor for the plants, for the flowers. So I use it on my flowers in Paris, but all the flowers are dead now. Not because of the sensor, but because it was very cold. And the second class is it's a Tesla Motors car, and they say the Tesla Motors is a connected computer on wheels. It's a kind of connected object, and this is an example of coffee machine. I didn't test because I don't like coffee, but I like Yocto. It's running Yocto. I don't know if it is really useful to run Yocto on a coffee machine, but it's fine for the demonstration. Yeah. So I will talk about Linux and IoT, and well, it's not a universal OS for the IoT and for the embedded, but there is a document called IoT Developer Survey last year, and they say the 73% of IoT devices run Linux, and the second one was bare metal, which is quite amazing, and the third was FreeRTOS, and the sixth, the fourth was Contiki. So it's all except bare metal is all free OS. That's a good news. But when you talk about Linux as an OS, don't forget you have so it is a bunch of distributions, and you can put Linux on a board without using a distribution. So the distribution such as Debian, Ubuntu, etc. is fine for developing, but it's not fine for, it is my opinion, for embedded system. And for embedded system, you use build systems such as Yocto, Buildroot, or some kind of build system, but Yocto and Buildroot are the most famous. So you know what is a Linux distribution, I hope so. So it's big and slow, but not so slow, but it's quite big. And now there is another problem. Most distributions, such as Ubuntu and Debian, they run on ARM. So it's easy to take a wrong way. So we have lots of customers. They buy an embedded board. They put Ubuntu on the board or Debian, and they say, well, we change it in the future, and they never change it except when there is a big problem. So they call us. And the good way for, one of the good way, in my opinion, for running Linux on embedded and IoT is to use a build system. So what is a build system? It's not a distribution, it's just a tool to create the distribution from the sources. And most of the time it does not provide the sources but only recipes. And when you run the build system, you have the binary files to be installed on the target, the bootloader, Linux kernel, etc., and you can provide additional information such as licensing issues or dependency graphs, etc. So it's much better for the footprint, for the boot time, etc. It's quite the same with Android. Android use a build system, but they provide sources. So it's 40 gigabytes. The size is 40 gigabytes. They provide their sources, and their version of external sources, and specific build system which is based on shell script, but it's open source. It's AOSP. So the most famous build systems are Yocto. The first one is Yocto. The second one, in my opinion, is Buildroot, and the third is OpenWRT, which is based on Buildroot. And the major difference between Buildroot and OpenWRT is the packaging support on OpenWRT. So OpenWRT is famous for the router, for this router, but it runs on some device, small device for IoT. This is a WeIO. It's an IoT device developed in Paris, but it's not very famous because in France we are not very good for selling things. So it's famous inside Paris, and it's quite a good device with OpenWRT, lots of sensor and very cheap, but well, not very famous. So Buildroot, it was a project from Microsilipsy, and now it's a real project with quite simple. It's based on Makefile, it's based on GNU-Make, and you can produce not really a Linux distribution, but a Linux firmware, because there is no packaging support. You run a Buildroot, you get an image, and you put it on the target, and you can change anything. So well, Open Embedded was the first project before Yocto. It's a cross-compilation framework. It was started for this device, which is quite old. It was the first, as far as I know, it was the first PDA for running Linux and Qt. It's quite famous to when there is a Linux distribution for a device, most of people, they want to develop another one. Not for using it, but for the pleasure to develop another one. And that was worse because the people, they work on OpenSource, but they develop the tool to develop OpenSource. And the tool was Open Embedded. So Open Embedded is based on recipes with a specific tool called BitBake, and all the components are based on recipes from the hello world to the world distribution, and that's quite different from Buildroot. There are classes, headers, configuration files. You can inherit from classes. You can derive a recipe, which is very useful. We'll speak about it. And the files are organized at layers. And there are packages. First, it was IPK, which is a very small packaging system. But now the default packaging system is RPM because it's Red Hat put some money in the Yocto project, so well, and lots of people use Red Hat in industry. So Yocto is a unit prefix for the metric system. So it's a very small distribution, not really this size, but it's the smallest prefix. So it was started 7 years ago by the Linux Foundation, and in order to integrate all the projects for around Open Embedded, because the current documentation of the sub-project around Open Embedded was awful. There was nothing except to be done. So there was lots of documentation. So it's quite complicated to use Yocto, but now you have a very good documentation. So well, and lots of embedded companies, including hardware makers and device makers, software editors, they are members of the Yocto project. And there is a guy which is the chief of the projects such as for the Linux development. And for us, it's very important as a service company, it's very important to know Yocto, and for the customer too, because most of Linux BSP today, if you buy a module, you have the Linux BSP is a Yocto layer, open embedded layer. So if you don't know Yocto or open embedded, you can build your system. You can't build your system. So it's well, this is a classical workflow. The main difference between Buildroot and Yocto Open Embedded is that you generate the packages even if you don't put the packages on the board. Inside the system there are all the packages. So if you just have to add an option to put the packages on the board. It's quite interesting. So it's a system based on layers. So you have here you have the basic layers, the core layers and the Yocto layer, and then you can put your layers, so additional layers up on the previous layers. The first one is a BSP, of course. If you don't want to run QEMU or basic PC, then you can add anything you want. And for example, you can add a IoT layer, or you can build or get from external sources. So some code. If you want to build a Yocto distribution for Raspberry Pi, the first step is to clone the right branch. It was based on Krogot, but now there is a new version. You clone the Metal Raspberry Pi layer. You start a build directory. You add the layer with a script. You set the machine name. You build the basic distribution, and then you generate an image for the SD card. It's quite simple. Well, when you know how to do. So the first use case was last summer, as we were integrated with a Smile company. Smile company was involved in open source, but involved in open source in web server, etc., not embedded systems. So they wanted to get a demonstration, so something like that. Sorry, it's in French. Something in French, some in English. So they have some demonstration just like here. And they need a sensor to get some data. So they called me to build a demonstration in one day, or about 1 or 2 days. And it was a demonstration based on a Raspberry Pi. It was not a Raspberry Pi Zero at this time, but for the FOSDEM I bought a Raspberry Pi Zero because it's very smart. And with a sensor, I2C temperature and pressure sensor I got from Adafruit, yeah, I don't know the name, yeah, Adafruit in France. A Wi-Fi USB, and we use the HTTP protocol because it was very simple, so that was nice. So I decided to start from the smaller distribution, which is called Core Image Minimal, and to add the right package, because you can build a very complicated distribution with lots of packages, but I would start with a very basic distribution, and the basic distribution without the packaging system is about 15 megabytes. It's not very big for a Linux system. And then I add some options, package management, standard or derivative recipes, and new recipes, for example, to control the sensor. And I put everything in a Meta IoT layer with a script, Yocto layer. And on Yocto, you have a local.conf, which is your local configuration file to build on your build directory. But it's only for the test, because you can add lots of options on a local.conf, but if you give the distribution to another guy, he should not do the same thing. So you have to build a dedicated distribution at the end, which is called RPI IoT image. For the the derivation was very interesting in Yocto. It is very interesting in Yocto. So the principle is quite simple. You have one recipe, which is .bb, where you define how to build the component in layer A, for example, and you write a new recipe, not a new recipe, a sub-recipe, which is called a BB append, in another layer. And in the second recipe, you can change, add files, change files, etc. But you don't change the main part of the recipe. It's not that's the best interest. And so for example, for the example, we modified the network configuration. We changed just one line, ETH0 to the WLAN0. It was very difficult. We had HTTP server like HTTPD. We activated I2C in the config file of the Raspberry Pi, and we had to load the I2C dev module. So, for example, in the basic distribution for the Raspberry Pi, only the Ethernet interface is started. So we have just to switch from ETH0 to WLAN0. We had some additional packages with Imagine Happen, so AW, etc., etc. And we update the network interface file for WLAN0, and we use manually we start the network configuration with the binary WPA passwords. Starting I2C for the Raspberry Pi is quite simple. It's not activated by default, so we have to modify the configuration file, which is config.txt, and to add a function which is executed after the deployment phase. So it's called do deploy happen, and to modify the file. And then we add the tools for the I2C and the kernel modules, because the basic distribution doesn't include the modules. You look like a snake. You are green and then you modify the kernel. You modify the kernel recipe just to add this line to add the automatic load of I2C dev. And we have to write a control room, a basic C program. There was a basic C program from the internet. It was based on RhymePy. RhymePy is a library for Pi players, and it was packaged in the Meta Raspberry Pi layer. And we started a service, very basic service, on just like on all good old Linux and good old Unix, without systemd. Just with a script which reads the sensor every 20 seconds. And we have a class to build such a service. So I can show you some piece of code, maybe. I need So for Yocto, just an example, Meta IoT. So some standard names for the recipes directories. It's a way of programming on Yocto. You can put Toto inside of recipes core. For example, in order to change in order to change and then you add a new file with automatic starting on WLAN0. A bit more difficult. if you develop the script, the program, so it is the program to control the I2C sensor. Is one C program, and you add some files to write a simple script to build a dynamic web page. It's very old-fashioned. It's just for the demo, but I like the old-fashioned things. I'm a dinosaur, so that's of course I like. Okay. So you can. So is it possible to get the Android hotspot? We can start a bit demonstration. I hope so. So you can see the P0 booting. It's quite fast for Linux. Should be. Without the network, it's faster, but without the network, it's difficult to get IoT running. So. Okay, it's okay. So, is it okay for? Well, I have a problem with my my PC. It's okay on the board, but not on the PC.
Try the FOSDEM option.
No, because I need to be on the Android hotspot, but I don't know why it doesn't work. Shtuk. What? I'm not sure. Ah, okay. No, not FOSDEM. Not FOSDEM. No, not Dream. Okay. Okay, but it's not a problem. Tempo HTML. So yeah. So it's a 20.7 degrees here. I'm not sure, but it's okay. Yeah. So it's don't remember 43.50 up. Ah. 150, why? 150, yeah. Okay. Yeah. Okay. And it should change. It should change if you put your finger. Ooh, it should change. Well, it should change. Yeah. Refresh. No, but there should be an automatic refresh. But okay. No, it's. I will die. I will die. I will die. Okay. It's very cold in Belgium. We have 36 seconds. So just to talk about another use case is just some words about a work was done by Nicolas Aguirre in Toulouse. It's more a complex demonstration based on real IoT device with 6 LoWPAN, and we use a Raspberry Pi as a border router running Yocto. And it's based on a sensor tag. It's a device from Texas Instruments with a Cortex-M with low power. It's a real IoT device. And we use a software which is called 6LBR, border router software. So you get the data from the tags, you send to the cloud with MQTT, etc., etc. And you can use Grafana to see the values with the web browser. It's very famous today. Grafana, everybody speaks about Grafana, so But it's fine. I don't understand how it could work, but it's fine, very fine. Okay, if you have some question, well.
One or two questions.
One or two questions.
Or no.
Or no question. It's better no question to get the time.
Everything was clear.
Yeah, one question.
You said you use RPM as the default package.
Not me, the Yocto project. You can change it in the, yeah. The question was, you say use RPM in the distribution. You can change it in your configuration, Yocto configuration, but this is the default. If you want a smaller distribution, you can use IPK, and it's half the size. But I use RPM as a test, but you can use IPK. It's much better for embedded.
And second question, do you use the libc as well, or it's glibc by default, or it's uselibc by default?
The question was about using Musel or glibc. It's glibc by default or Yocto. I don't know if you can build a cross compiler with Musel on Yocto. You can do it on build root, but I'm not sure on Yocto.
Yes, we can.
We can? Okay. We can.
Yeah. Okay, I'm afraid we'll have to take other questions outside.
Outside?
Yeah.
Okay?
Thanks a lot.
Thank you. Merci.